Hello all, good afternoon. Myself Sridhar Bijala. I'm heading global product support. I'm responsible for all the MeshWorks technical support activities. And I have my colleagues Rajat and Sai Prasanna with me. And today's webinar, we are going to talk about rapid multidisciplinary optimization and topology optimization workflows. So before getting into the technical part of it, I want to spend a few minutes addressing who we are and what we do. So we are DEP, founded in 1998, and we are the creators of MeshWorks. We, headquartered in Troy, Michigan, and we have offices in India, China, Japan, and Canada as well. And we also have distributors in Europe and France, Italy, South Korea, Turkey, and Spain. And we have in-house R&D presence globally, and we are we are into four verticals: the engineering consulting, software development and solutions, product development, and talent acquisition. And if you look at the screen, wherever it is marked as red, those are the offices. These are our own offices. And wherever it is marked as blue, there we are, working with our distributors. So we are 500 plus engineers, and 70% among them are, the masters and above. And if you look at the screen, these are some of the customers we are currently working with. And this is just to give a glimpse, but we do work with many of the automotive, aerospace, or the heavy equipment, biomedical, and whatnot. And our journey, as I said, we have started in 1998 at the North America office, and in 2020 we started our office in Chennai, and our first MeshWorks launch happened in 2001, and we have moved to bigger premises in Chennai in 2007. Followed by in 2013 Troy office, where we moved to a bigger office. And going to the technical part of it, in the previous webinars we have covered meshing, model assembly kind of workflows, and in today's session we are going to discuss advanced workflows like rapid multidisciplinary optimization and topology workflows. So with that, a user can do a quick optimization study, which saves a lot of time, as well as improve the performance. So if you the current trend in the CAE world is the start point will be CAD, and then the product will follow all the different steps like meshing, model assembly, then doing simulations, virtual validation, maintenance. So it involves all these steps, which takes a lot of time, because most of the time will be spent at the CAD phase. But whereas the new trend, which is like the MeshWorks trend, we have very advanced tools which cut down the CAD development time drastically by using our rapid ConceptWorks modules and parameterization and morphing techniques. A user can rapidly do the optimization, improve the performance, at the same time keeping the lower mass. And we can run a DOE-based optimization and achieve the better results in a quicker turnaround time. So with all these tools, it will cut down the CAD development time in a drastic way. So along with that, in the detailed virtual validation and the maintenance phase, also we the MeshWorks provides equal support by using different assembly modules and the CAE parametric capabilities and topology optimization modules can be applied to further reduce turnaround time. And regarding the topology optimization, we pretty much deal with the component level, full vehicle level, or even the assembly level. So in this scenario, like we are talking about a component level where you pick a solid model, and the process involves like you apply all the parametric attributes to the model, where you can minimize the design by reducing the wall thickness, or reducing the thickness of the rib. Such kind of parameters can be applied to reduce the model. And further reduction, you can also remove the existing features. Like if you look at the top image, you can remove all the the ribs, dog houses kind of features you can remove. And the next step is to create a design space. So that so we have this advanced tools where you can in no time you can fill the design space. And once the design space is created, we can run a topology optimization using any of the solvers present currently in the market, like a Nastran or OptiStruct. And once you have the topology results like an isosurface, you can use that isosurface image and build your own concept design, like what you're seeing on the bottom image. So you can pretty much create a rib between two dog houses, or you can increase the wall thickness of an existing rib or an existing wall, or increase the diameter of the hole. So all these parameters are possible with MeshWorks, with which you can do a fast optimization. And if the design pass, you get an optimized design. If not, the whole chain will repeat. It like an iterative process. So here again, I'm going to show you some of the scenarios where we talk about the tetra level, a component level, and the same story. And I'll just move on. So this demonstrates how quickly we can defeature an existing feature, and how quickly one can create a rib considering the isosurface. Likewise, you can also create the design space for a structural model, like what you're seeing on the screen, like all the, and also you can also create a concept design using these tools. So the same thing can be applied on sheet metals, plastics, as well as tetra, and even a full vehicle level. So with this, I'll turn it on to Rajat and Sai. Before that, I want to, so these are the demos which Rajat and Sai are going to do a live. So we'll start with the defeaturing of a tetra model, design space creation for a tetra model, then creating a concept design for a tetra model again. And after that, we'll also show you some solid boss creation on a solid model, and a vehicle level design space creation for a topology optimization. And we'll also show you how to create a quick tetra rib, or a shell rib and a shell boss on a plastic part, or even a honeycomb kind of structure. How quickly you can insert on a plastic part. With this, I'll turn around to Rajat and Sai. Rajat, you can start sharing your screen.
Thank you, Sridhar. I'll share my screen. Hope my screen visible.
Yes.
Yep. So I'll start with the feature removal tool that we have over in MeshWorks. What you see, the component over here is the gearbox model. So in this local region, I have segregated these ribs into shell components. As you can see, if I turn off the solid, these will be the shell components, right? So in order to use the feature removal, we need this shell elements as an input. So going into the feature removal, in the basic mesh panel, we have the feature removal tool. And over here, we see the skin coating of the feature, which is nothing but these shell elements. Wherever you want to create, whether you want to remove a bosses or a shell ribs, anything can be selected as a shell elements. Now, once selected, when you click on remove feature, it will identify the regions. It will first remove the features that we have selected and identifies the regions along which it will be doing the remeshing once after the removal has happened. So when you click on accept, it finalize the region and remeshes according to the given element size. So in this manner, we can remove several features as needed in the model. Now going on to the other demo, which is design space filling. Same, we have the gearbox SM model here, and I have extracted the feature lines, 1Ds, along this region of the gearbox. So which is basically needed as an input for the design space filling tool that we have here in the advanced mesh panel. So here we can select the tetra components, which is nothing but the entire model. And in the next, we have to select the 1D elements, so nothing but 1D components. And when you hit on create design space cover, it actually creates a 2D shell cover around this region. It will take about a minute or so in order to create that design space cover. And after that it's created, we can adjust the cover using the adjust cover option. So this is how the design space cover is created, as you can see, which is nothing but a 2D shell cover. So we can adjust the cover dimensions accordingly by selecting some few elements in the cover, and we have all these options on how to proceed for the adjustment, whether we can offset, rotate, scale, or translate. I'll be going with the offset, and we click on that, and here we have this panel in which we can select the nodes, which is nothing but the element selected previously, and we can click on offset plus or minus to adjust the height accordingly, as you can see. And when you click on accept, offset is completed, return out of the panel, and when you click on fill design space, it actually fills the entire space cover with the solid tetra elements. It will take a few seconds to generate the interior solid model, as you can see. So this is that entire design space which was filled with solid elements. I'm going to bring back the entire model, and I hide some of the region. You can see the entire gap is being filled with solid elements with the connection nodal connectivity as well, as you can see. When I click on find attached, find layers, it propagates all the way. So this is how we can fill any create any design space and adjust the model for the minimalist design possible. So next up, I'll be showing the tetra boss creation. So the model that you are seeing on the screen is a gigacasting model, which is a solid model, as you can see from here. So I'll be creating a solid boss in this region. So for that we can go into the basic mesh panel. We see a boss creation tool. So under here we can either select any one of these options available in order to give the input for the boss creation. I'll be going with select faces. I'll be selecting a face in this region and select the entire model as a master component. And when you click on preview 1Ds, it will highlight these faces and it will generate a shell face on top of it. On this, we can actually use this face as a reference in order to create a boss. So I'll be, let's say, panning this onto the side. So let's say I want to create a boss in this exact same region. Right, I can either pan or rotate as well. And when you click on create, it will generate a boss in that region based on the selected face. Yep, as you can see, the solid boss has been created. So this is one method of creating a boss. So another method is with the 1Ds elements option. Here we can create the profile of an 1D in whatever shape we want to create the boss for. We select the 1Ds. Yep, and select the master component in the same manner. And when you click on boss creation inputs, so in this panel that you see here, that we can have in this boss. So the tool is intelligent enough to identify the inner and outer 1D elements. So as you can see, the outer one will be the fuse, which will be the fusing onto the solid body, and this cut is nothing but a hole that will be going through the boss. So I can either give a through or a blind hole. I can specify the length of the hole and necessary draft angle as well. So I'll be inputting, let's say, a hole 30 mm, let's say.
Right.
And when I click on accept and when I click on create, it will generate the boss in the same manner that we have provided the inputs for. As you can see from here, the boss has been generated. I can measure the distance. As you can see, the hole has been generated 30 mm from the top surface. So this is on the solid boss creation tools. Next up, I'll be showing you the tetra solid rib creation. In the same model I have created here, right? So I'll be creating a rib in between these two. For that, I'll be going into the advanced mesh panel, and here you see tet or shell rib creation. So I have checked on the convert to solid rib because we want to create the solid rib over here. And I'll be going by select faces option, in which I can select the desired space in which the rib will be connecting to the components. Let's say I want to create a rib between these two bosses. So I'm selecting all the connecting faces on both sides. So yeah, once it's done, I'll be defining the plane. For that, select the nodes. And select the center node along which the plane will be passing. Specify the size of the plane. As you can see, so this is how the plane will be generated, in which the rib will be connected along this plane. So once it's done, when you return out of this panel, it will highlight the region in which the plane is created. And for reference nodes, I can select any two nodes in this plane region. So it will ask for input, in which you can sketch the rib according to your desired shape. For that, I will select the endpoints of the bosses, and we can modify the curve as well using modify curve option. Once it's done, I'll click on accept. I'll bring back the geometry. If you click on preview profile, it will show how the rib will be created before conforming. You can see a shell rib has been created in between these two bosses. When you click on preview profile, you can also specify the fillet radius and number of layers, and you can also remesh the fillet. You can also specify rib thickness. I'll be going with the default, and when you hit on create that rib, it will actually take this as input and creates a solid tet rib in between these two bosses along with the fillets. So either the rib can be a linear one or a smooth one based on whatever your requirement is. Yep, as you can see, solid tet rib has been created between these two bosses along with the fillets. So yeah, these are some of the tools, interesting tools that we have in MeshWorks, and I'll be giving it to Rajat to demonstrate the further demos. Thank you all.
Thank you, Sai. Let me share my screen first. I hope you're able to see my screen now.
Rajat, we can.
Yeah, thank you. Okay, next I'll be covering the vehicle space creation. So if you want to create a design space for any component, we can quickly do so using MeshWorks. So the first step would be to create the outer boundary. So select the components and then select the nodes, the boundary nodes, and then and specify the direction, and it will create a 1D around the outer boundary, 1D elements around the outer boundary. So we will do the similar process for the other three locations as well. Again, I'll select the components. Then I'll select the nodes. And the vector plane. And it will create a 1D elements again. Do the similar process here. Okay, 1D. So next we'll create a tria mesh around the component, and it will be the tria mesh will be created using it will be doing an offset and it will be creating a tire mesh. So meanwhile, in the next step, what we would be doing is creating sidewalls around these 1D edges. The final intention is to create a closed structure so that we can create a tetra mesh, create a design space with tetra mesh. So that's the process we'll be using. We'll be creating a sidewall next and creating a closed mesh. In the interest of time, I'll be showing it in other model. Let me first show you the output for the tetra mesh. So it has generated this tetra mesh. I'll hide the component to show the tetra mesh. So it will nicely create a tetra mesh around the region. And as you can see, it will create a purple color. You can see the purple color component over here, elements. So what the tool has done is it has covered the holes with tria mesh again to create a completely closed structure. So as I said previously, the next steps would be to create a sidewall around this region here, and then we'll be creating a closed mesh tetra elements, and then after we have the closed structure, we'll be generating a tetra element. So in the interest of the time, I will directly show you the structure. You can see the closed mesh over here. So the next step is to create a tetra element. Let me again go to the tool. We have to go to special tools, body structure design space interior, and select the component for creating the tetra element, and click on create tetra. Again, it will take about a minute or so to create the tetra element. And so we're using MeshWorks, we can quickly create a design space of tetra elements for topology optimizations. So it has generated the tetra element. Let me hide the shell elements in auto color. So it has generated the tetra elements with you can see the RB elements over here. So that it connects to the shell elements as well. So the tetra element is connected to this shell elements using the RBs. Yeah, so I was talking about this component. So after generating the tetra elements, you can see the tetra elements over here. It will generate the RBs, which will connect the tet elements with the 2D shell elements. So next I'm going to cover the shell boss, how to create shell boss. So Sai has previously shown you how to create a boss elements on a 3D component. I will be showing at a shell level. So let me share a particular screen. Here we have the giga casting, which Sai showed, but this comprises of shell elements or 2D elements, as you can see over here. So I'm going to show you how we can quickly create bosses on shell elements using MeshWorks. So we'll be using the ConceptWorks to create the bosses, and we have a quick boss option over here. So all we have to do is pick the center, specify the outer diameter, inner diameter, and the height. It will translate as per the height that we have provided, and click on extrude. So all we have to do is give these 3 inputs, and it will quickly generate the bosses on a shell bosses on this component. So it has generated the bosses, as you can see. And it has nicely captured the region around the bosses. Now, using a similar process, I'm going to create another boss right next to the previous boss. I'll use the same inputs and say extrude me. So it has generated another boss right next to the previously created one. So now I'm going to show how we can create shell rips on this between these two bosses. So for that, we have to go to the meshing panel, advanced mesh, shell rip, shell rip creation, and select the base component. And then we have to define the plane along which the rib will be created. So I'll be picking 3 points to define the plane. Specify the plane size. Select the node along which the plane is going to pass and say execute. It will create a plane along which the rib would be created. Next, I'm going to create select the reference node, which will define the starting and the end point of the shell rib. And then we have the sketch rib option over here. You can simply, as Shai showed previously, you can sketch the ribs. So this is the sketch of the rib. And if I click on preview, it will give the preview of the shell rib. And clicking on execute will give the connection between this shell rib and the base component. So you can see the connections between the shell rib and the base component. So using MeshWorks, we can quickly create for topology optimizations. We can quickly create bosses and shell ribs at any locations quickly. So next, I'm going to show how we can create honeycomb patterns in MeshWorks. So I'll be creating a honeycomb patterns in this component using MeshWorks. So again, you have to go to the shell rib creation option and select pattern rips. And all we have to do is select the base component, base elements, and the die pullout option. We will define the pullout direction. So the honeycomb patterns would be created in the direction of the pullout. So I'll define it by selecting 2 nodes. And then we can define the inputs. So here I'll be selecting the honeycomb pattern. We can have our own custom patterns made using 1D elements, lines, or edges, and specify it as an input. So I'm going to use the already existing one, which is the honeycomb pattern inputs. Select the diameter of the honeycomb, number of rows, columns, and click on create initial pattern. So it will show the preview of this pattern. So this pattern would be imprinted on the base component. We can adjust it however we want using this position option. So I can if I click on plus, it will move to the right and it will move to the left. And again, we have options for moving vertical along the normal. We can rotate it if you want, and so on. So I'll click on preview pattern and it will show the preview of this patterns on the base component. So it is identifying the locations and showing the preview. So along the pull-out direction, the patterns would be created. When I click on execute, it will create the patterns. And we can provide the extrude height here as well. So it has created these honeycomb patterns in this region. Yeah. So these were the demos we planned for the topology optimization. I showed how we can quickly create uh, design space using MeshWorks, and how we can easily create shell bosses, shell grips, or these patterns on the components. So thank you very much. I'll give it over to Sridhar for the next steps.
Thanks, Sai and Rajat, for the wonderful presentation. So, next few minutes I'll spend time explaining, the uniqueness part and the value proposition of all these wonderful tools. So, So the topology optimization workflow, if you consider, what makes it unique, the whatever demos you have seen now, the whatever Rajat and Sai presented, how quickly you can remove existing features. So with this automated tools, it can handle very complex geometries, and in a very short turnaround time, you can remove an existing feature. Likewise, how quickly you can create a body fitting design space in a in a highly automated fashion. So all these are possible with this advanced tools, and also how quickly someone can create a ISO surface, a beam model out of an ISO surface. So that's possible. And the availability of advanced concept tools such as member creation, joint creation, and doubler bulkheads for casting, stamping, extrusion, and plastic parts is a very easy and piece of cake when you use our MeshWorks advanced tools. And the value proposition of it is like one can achieve a minimalistic design using the topology optimization workflow, yielding a maximum weight reduction compared to any of the optimization workflows available in the market, and at the same time keeping the performance in a in a same stage. And you can also save a lot of tremendous time reduction. Both in the pre and post processing point of the workflow view, and using our highly advanced the process automation models. And MeshWorks also helps in skipping all the designer phase, with which user can save tons of simulation time directly using our concept FE generating tools. Let it be from a topology results, or starting from the CAD curves. So everything is possible using these tools. And MeshWorks has a complete set of tools to handle both component and assembly level, and you have seen in our live demos today. So we can pretty much handle all the different complexity. We can we will also consider manufacturing, casting, extrusion, and stamping parameters when we create any concept design. And if you have to talk about the MDO part of it, the multidisciplinary optimization, the start point can be, you select any one of, one domain model. Let it be a crash LS Dyna model, and you create all your parameters, right from a shape parameters to adding some bulkheads, doublers, and creating some weld parameters, gauge, material. So all the 3G parameters can be applied on a crash model, and in a very automated fashion, all those parameters can be imposed to a durability, NVH, and CFD models without having to spend equal amount of time redoing all this, parameter creation. And in a automated fashion, you can run all this, DOE, and the IO matrix is achieved out of the analysis, and you can apply all your response surface and the process integrations with all the design variable limits, etc. For your topology, for your optimization study. And if you achieve an optimized design, your loop ends there. If not, you can again repeat the same process using our advanced MDO approach. And here, I'm going to show you some of the examples on the MDO. So this is again the same slide, and I'll just move on. So yeah. So if you look at the screen here, on the left-hand side, you have a full vehicle crash model. On the right-hand side, you have an accident model. The parameters on the crash, are imposed onto the NVH. So that's what you're seeing here. In a similar fashion, if you consider, the powertrain model, you have a durability model and a CFD model, and you have some parameters created on a water jacket as a thickness parameter. The left hand side, the CFD model parameters can be straight away imposed onto your durability model. That way you can save a lot of time. Similar fashion, you can also apply the ROM capability to the MDO. So on the left hand side, you have a beam NVH model, and on the right hand side, you have a crash rear portion converted to a lump loss. So still the parameters can be imposed in a very quick turnaround time. And if you have to talk about the parameterization capability in MeshWorks, you can pretty much do start from a shape parameters to gauge, material, and also we have a very huge list of parameters which a user can apply to their optimization workflow. Like adding a bulkhead doubler to improve the performance of crash model, or creating a tailored welded blank for your side impact. So all this is possible using our MDO tools. And if you look at another example, left hand side you have a crash PetPro model. On the right hand side you have an NVH food model, and the parameters can be imposed from one to another. Rest of time, I'll just skip this slide, and we'll discuss about the what makes it unique. So using our highly automated transposing parameters from master model to a other disciplinary models, it's a unique feature which is not available in any of the competitive tools. And MeshWorks offers the widest range of parameters for diverse problems, maximizing the design space and hence the extent of optimization. So if someone have to create a parameter, you can start from a shape and you can continue using all the different parameters available in the MeshWorks module, like a gauge, material, and adding all the enablers like a bulkhead doubler, slots, holes, or a bead kind of parameters can be utilized for your optimization workflow. And using our parametric rigid order modeling technique, it's a unique function. Again, it's available only in MeshWorks, so that makes again MeshWorks very unique. And our seamless integration process with any of the optimizers available in the market, like you can pretty much integrate MeshWorks with iSate, Moon Frontier, Heats, LSOpt, or the Optimus kind of optimizers for your optimization workflows. And when it comes to the value proposition of the MDO, MeshWorks-based MDO optimization process enables to achieve achieve a huge mass saving and as well as a cost saving, maintaining a balanced performance across multiple disciplines. And with the integrated ROM approach, with adding its addition to MDO, which can significantly reduce the analysis runtime, because you are kind of reducing the model in a size so that a 20 hours kind of simulation can be cut down to 40%. Like it can finish in 12 hours or 10 hours kind of turnaround time can be achieved using a ROM plus MDO approach. And MeshWorks MDO follows inclusive methodology that incorporates both, like all the different factors like manufacturing, packaging, human factors, and other design aspects along with the structural consideration, resulting in a balanced optimization. With this, I'll conclude the presentation today. And this new version empowers users with the capabilities of CAE at their fingertips. We follow transform, accelerate, innovate, and automate as our parameters. So if you consider the transformation phase, you can apply all our CAE and CAD morphing and concept modeling and parameterization attributes to so that you can transform your workflow. Likewise, using our reduced order modeling with a multidisciplinary optimization workflow, you can accelerate the process by cutting down 30 to 70% of the simulation time. And you can use our innovative EMOD or AI/ML capabilities for your innovative projects. And using our automatic process automation modules, you can again save a lot of time whenever you have a repetitive workflow like a meshing or a model assembly or kind of analysis setup. Those all can be pretty much automated using our process automation module. You can send any queries you have to this email here, so that we can revert you back with all the necessary answers. Thank you.
Thank you all for joining. We'll be closing the session now. Thank you.